So if we now go again to the result time series plot, so again we click on the icon right next to the yellow little man, and we go to see the reach that we actually modified, which is in stream number 1. So we select stream number 1 from the top left drop down menu. It will go automatically on reach number 3, so we don't need to change that, and we see that it's a huge difference. There is a huge difference in terms of flow. Obviously, when the flow was nearly 0 in the previous scenario, in normal scenario, in the baseline scenario, now is around 1. Obviously, we introduced 1 cubic meter per second. What has changed also brutally is nitrate and ammonium concentration. Now we have a nitrate concentration around 10 milligrams per liter, and which is very, very close to the water framework directive value, which is around like 12, 13. So we might have a problem now. And the ammonium is very high too, which I don't remember the limit of the water framework directive, but I'm sure this is over the limit. So yeah, that is just very, very briefly how you can use the scenario tool for running Inca.
Could you try reducing the quantity of water?
Yeah.
So I don't know, a sort of drought scenario.
You can
change precipitation values.
it depends on what you do. I mean, the water that you have in the river depends obviously on what is raining. So if you want to analyze what is going to happen if it doesn't rain as much as usual, so you somehow need to change the precipitation. So you can just change it manually, inventing a scenario, which is something that sometimes we do. We just alter the observed precipitation series, and we reduce it, for example, by 10, 5, 10, 15, 20, 25, 30%, and see what happens to water quality and water quantity too. Another way is to use a meteorological model or a climate model. So you can just, which is what we are doing in Marius, for example, generate scenarios that are realistic because they are supposed to be close to the reality, because they are generated by a climate model which is reproducing the weather, the actual weather. And that's the 2 ways you have to change the precipitation, as she said. But another thing that can affect the amount of water that you have in the river is abstraction. And you can do that with Inca. So at the same way we set an effluent, we can set an abstraction. We can have a look. If you click on Edit Parameters Reach again, and you can go to any of the reaches, to the effluent tab. On the flow tab, where we wrote 1 before, just below we have abstraction, and use the same. Your right value in this case is just a constant abstraction over time, so you just write 1 cubic meter per second, and in your abstracting 1 cubic meter per second, obviously it doesn't make sense here because the flow is almost always below 1. So the abstraction is not going to be performed almost ever. But obviously we do that for the Thames because the flow abstracted in that chat is very important for the hydrology of the river Thames. You can also use a time variable series of both discharge, effluent discharge, and abstraction. So you prepare a file that is very similar to the input file, the data file that we saw before. It has a similar format, but instead of having the precipitation, temperature, etc. in it, it has a time series of the flow that is discharged and the flow that is abstract. If rather than a flat abstraction of discharge, you want a variable time series, you can do that with Inca. We're not going to see that, but you can.
And it's just one value, so you couldn't say, for example, have more abstraction going on at
times of crop watering and then
that's-
different for the winter or whatever. It's just a one.
That's what I was saying. Here you can just change this one value, but Inca also gives you the possibility of providing a time variable abstraction with the external file. Actually, if you go to File, Open, and you go to the drop-down menu of the extensions, after the observed there are several extensions. One is the .ets, which is the effluent time series. This is the format of the effluent time variable file. So with the .ets, you provide to Inca a variable discharge to discharge into the river, and with the .abs, the abstraction time series, you do what you just said, which is you can tell the model the abstraction is not just the same all the time. It changes. It can be higher in summer or lower in winter or whatever, or the opposite.
So then, supposing you modified that, what would you put in the drop-down window box? Do you put something to indicate so that the model knows to ignore the value there and to look at that?
If you upload a file, the model already knows, to let it just to ignore. It also depends on the reach, because in the file you may want to define the time variable abstraction of one reach. So for that one reach, the model will ignore the value you just wrote in the interface. But for other reaches, it will not ignore it. It will use the value that you wrote. So you can play with that. And since we have this open, we can have a look at the other extensions. For example, spatial time series is if instead of one time series of precipitation, you want to have more than one. For example, if you have a very different precipitation in the upland and in the lowland, obviously for the Salmons Brook, the precipitation is the same in the upper part and the lower part. Even for the Lee, there isn't much gradient of precipitation for the upper part of the Lee or the lower part for the Lee. But we have, for example, modeled some catchments in Wales, the Conwy, the Severn, the Wee, the Wye, and you have like 3,000 millimeters per year of rainfall up in Snowdonia and 600 millimeters per year down in the lower part, which is hugely different. So you need to consider that.